Hello, this is Brother Cromer from the Math Department at BYU Idaho, and this is part 2 of Lesson 22 dealing with describing bivariate data, scatterplot correlations and covariance. So we talked about in the last video scatterplots and correlation coefficient, but now we're going to deal with the covariance. Okay, so I'd like to do is go to the next slide here, talk about the covariance. Now the covariance, the formula for it is, and this is how you denote it, it's S subscript xy for the two variables. It's the correlation coefficient times the standard deviation of both variables. Now we're interested in the covariance because it's a measure of variation. Okay, it's a measure of spread. Now, if we're interested, say, in just the one variable, the x variable, say powerboat registration in Florida, and we just want to isolate that, then we can just look at this and get the standard deviation for it, and that's it. But since we're looking for the relationship between manatee killed and powerboat registrations, we know that they'll affect each other, and so it'll also affect the measures of spread as well. So we want to calculate a covariance. Okay, and so the covariance is R times both standard deviations together. Okay, so here's an example of the manatee killed versus powerboat registration problem. So we have our correlations, our correlation and our two standard deviations. So we can calculate the covariance by taking the correlation coefficient 0.952 times the two standard deviations, 1.76, 0.75 times 24.16. The first one is the standard deviation of the powerboat registrations in Florida. The second one is the standard deviation for manatee killed. If we multiply all this together, we get 4,064.73. Now, if you want to, please stop the video and try to figure out the covariance of the relationship between mileage and price. So if we calculate this, what we do is we take the correlation, which is negative 0.868, times the standard deviation of mileage times the standard deviation of price, and we get a big number, which is 78,788,149.63. Now, a thing to remember for this is that if the correlation is negative, the covariance will also be negative, and also if the correlation is positive, then the covariance is also positive, because standard deviations can never be negative. They'll always be positive. So if this value here, the R, is negative, covariance will be negative. And if this is positive, then the whole thing will be positive. Okay? So now let's talk about the effects of outliers. The effects of outliers, this is the graph, 3 graphs that I got from the online textbook. Now, this outlier here, compared to everything else over here, notice what happens to R here. R is equal to negative 0.37. Now, if this outlier wasn't here, say for instance we yanked it out, what type of relationship whatever this imaginary x and y variable would be? Well, in this case, this would be positive, but notice here this is negative. So this outlier had a huge effect on this relationship between whatever this x variable is and this y variable. Let's look in the middle here. For instance, this outlier is way over here while everything else is over here. Notice that now it looks like it's positive 0.62 here. But what if this outlier, if this were yanked out, what would happen? Well, it looked like this here would be a negative relationship. So as you can see here, go back over here to the left here. If we were to draw a line, this would make sense if we included the outlier, and then over here, if we drew a line, then it would make sense if this were positive. Okay, so now the question is, do we need that outlier or not? Well, now if it's just a data entry error, then we should yank it out. But maybe there's something else behind it that maybe we need to look into. So knee-jerk reaction is typically to throw it out, but sometimes we need to take a closer look at it so we can see what's happening with that outlier. Now the last item here is we have an outlier way over here, and then we have a blob of information here. Now, if we were to draw a line across all the points, it would make sense that this is positive. But what if this were an outlier that perhaps it was just a data entry problem? If we yank that out, then it looks like this would just be a blob of information. Perhaps R would potentially be 0. Okay. Now the last thing I want to mention on this video is nonlinear relationships. Now our primary focus is linear relationships, so I just want to mention briefly a couple of scatter plots that you might see. Okay. Here, now none of these are linear relationships. This here, there's two curves here in this situation. This here is an example of what you would call perhaps a cubic, potentially a cubic relationship. And then both of these down here, these here look to be what are called quadratic relationships. Now you notice here with both of these is that R for both of these are pretty close to 0. So it's pretty obvious that you can tell that that there's no linear relationship. However, with these ones, R is pretty big, but it's possible. So this is why you have to look at both the scatter plot and the correlation to see if it's a linear relationship. Okay, and so even though R looks like it might be a linear relationship, we need to take a look at the scatter plot to see if whether or not it is actually a linear relationship. But so you can't have one without the other. Just like love and marriage, like Frank Sinatra said, you can't have one without the other. You need the scatter plot and the correlation, and I think that's a good way to end these videos. So that concludes these videos for dealing with lesson 22.